Welcome back to Mileom.com. In this video, we will learn how to make an DI with thermogun using Arduino and MLX90614 temperature sensor. Now we will need a temperature sensor MLX90614 I2C OLED display, Arduino Nano, a button, breadboard, 9-volt battery, 9-volt battery cables, and some jumper cables. Before we start this tutorial, if you need detailed and basic tutorial on how to use the MLX90614 temperature sensor, you can find on my another video. And there is a complete tutorial on I2C OLED display as well. Just click the link in the description below. Let's start with the wiring diagram. We can see that both the sensor and the display are using I2C communication, so they will share the SDI and SDL pin, which are A4 and A5 at Arduino Nano. I begin with placing the Arduino Nano on the breadboard. Then I connect the Arduino with the sensor. Connect the SDA to pin A4 of Arduino, SDL to pin A5 of Arduino, V-in of sensor to 3.3 volt. Yes, it's to 3.3 volt, not 5 volt. And the last, ground of sensor to ground of Arduino. After the sensor is connected, now I will connect the OLED display. The SDK of display go to pin A5 and the SDA to pin A4, then ground to ground and VDD to 5 volt of Arduino. Double check the wiring and make sure they are on the right pins. Now if everything seems correct, let's program the Arduino. Now I will start with the I2C scanner. You can download this sketch at the link at the description below. This sketch used to find the address of sensor and OLED display. Upload this sketch, and if it's done, open the serial monitor. And if the wiring is correct, it should show two addresses of devices like this. This is for OLED display and this is for the sensor. You should remember or copy the OLED display address. We will use it later. And if you don't have these two addresses, maybe your wiring still has problem. Double check the wiring. In this project we will need these three libraries. If you don't have yet, you can download and then copy manually to your library folder, or you can use Library Manager. To use Library Manager, open the Library Manager from Tools menu and then search for these 3 libraries and install all libraries one by one. The first is Adafruit SSD 1306. Just click Install. Then Adafruit GFX library. Click Install again. And the last is Adafruit MLX 90614 library. After the library's installation is complete, now I will test the MLX 90614 temperature sensor first. Just open the example and search for Adafruit MLX 90614, then open the test file. Upload the sketch and then open the serial monitor. You should able to get the temperature reading just like this. So it reads the ambient and object temperature about 29 degrees of Celsius and 28 degrees of Celsius, which is about right. It also reads in Fahrenheit. So the sensor is working fine. Now let's test the OLED display. Open the Adafruit SSD 1306 library sample. Look for SSD 1306 128 by 64 I2C. Now scroll down and go to the display address and change that address to the value that we got before from the I2C scanner. For me it's 0x3C. After the upload is done, you should now see the OLED display displayed something like this. Okay, now both devices are working fine. Let's try to program the Thermogun, which is actually just mix these 2 programs. And this is the complete sketch for this project. You can download the sketch and copy to your Arduino IDE from link at the description below. Before we upload the code, I will explain this code. If you are not interested in the explanation, you can skip this. Okay, so this is all the library we need. And then this is the size of the display, 128 by 64. This is the display declaration, and then this is the object of the sensor. And then we go to setup, begin the serial monitor, begin the sensor, and then we begin the display. After the display is begin, then we clear the display. Okay, so now we go to loop, and in the loop we call the function printTech, which is print the temperature to the display. So this is the printTech function. We set font to about 18PT7B and the color is white. We set the cursor at 0 and 50 pixel, and then we read the temperature and give it only 1 decimal value. After that we draw the circle. This is the degree symbol, and then we set the cursor again and print the C value. Okay, so this is the Celsius, and then we call the display.display to display all this text. After that we delay for 500 milliseconds and clear the display, and then it's looping over and over again. So it will printTech, delay for half second, and then clear the display and print again, delay and clear. So that will be looping forever. Okay, that's the code. Upload the code, and now you should see this. Let's test our Thermogun. So I place my finger in front of the sensor, and now we can see it reads my body temperature about 33 degrees of Celsius. So yeah, we have a working thermogun right now. But we don't want to stop here, so a thermogun should be portable, right? We don't have to connect the power to USB, so I will add a 9V battery, put the battery connector to battery, then connect the positive battery, which is red, to V-in of Arduino, and the negative battery, the black one, to ground of Arduino. And now our thermogun is working fine with a battery. Now to make the thermogun easier to carry, I will stick the battery under the breadboard and then stick the display on the side of thermogun using double-sided tape, and also put the sensor at another side using the double-sided tape as well. Now put back the battery wire to Arduino and let's test our thermogun. Hahaha. That's pretty cool, right? The cables and all messy stuff make it more, like a DIY things. And then I got an idea. How if we put a buzzer on it? So every the temperature reaches certain value, it will give us an alarm, a sounds. So I will put a buzzer, the positive lead to pin for Arduino and the ground to ground of Arduino, and we should add the program too. Let's add some line at the program. So I will make the pin 4 Arduino become an output because we put the buzzer on pin 4, so pin mode for output, and then I will make the buzzer sounds when the temperature is more than 37. So if the temperature is more than 37, then we will digital write pin 4 high because the buzzer at pin 4. And else, if it's not more than 37, then the pin 4 should be low or the buzzer should goes off again. Now we can change the print value to temperature, and let's upload the program. Okay, I should put the temperature variable as a global variable, so I will put the variable at top. You can copy this full code at the link in the description below. So don't worry. Okay, the uploading is done. Now let's test our thermogun with buzzer. You can see that our thermogun is work. Every temperature reaches more than 37 degrees of Celsius, the buzzer will make sounds, so it is an alarm. You don't need to always watch the temperature. Now if you want to use an on-off switch, just replace one of the battery cable with a switch. I will cut the ground battery cable and put switch on it. And you can also add a button, so thermogun only measure the temperature if user press the button. I will add the button to pin 7 of Arduino and another cable from button to ground. And we need to add some lines to sketch to enable the button. Okay, so we will add a button at pin 7, so I give a pin mode. 7 is input, pull up, then we will digital read the pin 7, so if pin 7 is low, if digital read pin 7 is low or it is pressed, then we will execute the program. So only if the button is pressed, the digital read 7 will low and will measure the temperature and will make the buzzer sounds and will print the temperature to the OLED display. So if it's not pressed, it will not measure and display the temperature. So just upload the code and it's done. And if you don't want these messy cables, you can make your own case. I also designed a case and built it using 3D printer. So this is my design. You can also download from link at the description below. And this is the result of 3D printed case. You can put all your components here. I think this is the end of tutorial. Let me know if you prefer use a case or without a case. For me, I prefer without a case. Maybe because it more looks like DIY. So don't forget to subscribe and see you in the next video. Bye.